Hey, we have here today another integral from the MIT Integration Bee 2023. This is from the quarterfinals, problem number 1. We have the integral from 0 to 1, x to the 4th times 1 minus x all squared over 1 plus x squared dx. Okay, I didn't quite know what to do with this. Didn't quite know what to do with the numerator, so I'm just going to kind of multiply it out. First, we'll do this piece, and if we multiply that out, we get 1 minus 2x plus x squared. And then what I'm going to do to put this back together, I'm going to multiply in this x to the 4th. I'm just going to reverse the order because I feel like it. So x to the 4th plus x to the 4th times x squared is x to the 6th minus 2x to the 5th plus x to the 4th. And then we'll have our x squared plus 1 dx. And now we clearly have a higher power in the numerator. We could try to manipulate this a little bit, but what I wanted to do, what I want to do with this, I'm just going to do polynomial long division and divide. We're going to want to divide x squared plus 1 into this whole thing. Okay, so let's do that real quick. So first, dividing x squared into x to the 6th, we want to multiply in an x to the 4th. I'll multiply x to the 4th times this. We'll have x to the 6th plus x to the 4th. This is going to cancel. This is going to cancel. And we'll have a minus 2x to the 5th. Then I want to go back, divide this again in here. Dividing this into this, we're going to have minus 2x cubed. Multiply this back here. We have minus 2x to the 5th minus 2x cubed. This is going to cancel. We're subtracting here, so we need to change the sign to a plus 2x cubed. Then one last time, we want to multiply here by a positive 2x. 2x times x squared is going to be 2x cubed. 2x times 1 is going to be a plus 2x. Subtracting, this is going to cancel and we're left with just minus 2x. So then the result, we'll use that to rewrite our integral to start. So we're going to have here from 0 to 1, x to the 4th minus 2x cubed plus 2x. And then we'll have this. I'm going to bring my minus outside. And we're going to have 2x over x squared plus 1. Sorry, running out of space. Okay, so the nice thing here is just power rule. So I'm going to integrate this. We'll have x to the 5 over 5 minus 2x to the 4 over 4 plus 2x squared over 2, evaluated from 0 to 1. And this is actually set up pretty nice because if I make a u substitution for x squared plus 1, we just noticed that du is exactly our numerator. So then doing this, we'll plug a 1 in here first. 1 squared plus 1 is 2. 0 in here, 0 squared plus 1 is 1. And here we're just going to have du over u. Now evaluating this, okay, 0. When we evaluate 0, it's all going to be 0. So we just need to plug 1 in here. We're going to have 1 over 5 minus 2 over 4, which is a half, plus 1, minus the integral of this. Okay, this is just going to be, so this is actually just going to be natural log absolute value of u, evaluated from 2 to 1. Now, if we have a common denominator here, this is just, like we can write this as 2/10 minus 5/10 is minus 3/10. So we're going to have 1 minus 3/10 is just going to be 7 over 10 here. Then we just need to evaluate natural log at 2. That's just going to be natural log of 2. And then we plug a 1 in here. Natural log of 1 is 0. We'll leave that off. And so our final solution is 7 over 10 minus natural log 2. So that's it. Not too hard. That was a pretty good problem from MIT. We'll stop it there. You can probably tell I'm still trying to get a voice back, but it's coming along. So thanks everyone for watching. Have a good day.